No breaks. Just math. Let's see how far I go. Problem 10. What is the mass in grams and the weight in dynes and in gram force of 12 ounces of salt? Local gravity is 9.65 meters per second squared. Use 1 pound mass equals 16 ounce. On this video series, we are going to follow these steps in solving different math problems. Step 1. Isolate the given. Step 2. Identify the requirements. Step 3. Integrate. Solve. Let's proceed. First, we isolate the given. Mass of salt is given at 12 ounces. It is represented by variable m. Another given is the local gravity g, or the acceleration due to gravity, which is 9.65 meters per second squared. And then lastly, a conversion factor is given, which is 1 pound mass equals 16 ounce. Second, we identify the requirements. We are going to find 3 unknowns on this problem, which are the mass of salt in grams, its weight in dynes, and its weight in gram force. Lastly, we integrate. We are going to solve first the mass of salt in grams. We recall some of the given at step 2. To solve for the first unknown, we are just going to convert the given mass to a different unit. Here is the flow of conversion. Using the given conversion factor, we convert ounce to pound mass. Then we proceed in converting pound mass to SI units until we reach the desired unit. And then, we have this line of equation. We used 3 conversion factors to obtain the desired unit. Then, we cancelled out the units. Finally, we get the mass of salt in grams, which is 340.14 grams. We box the answer and the first unknown has been solved. Next is that we are going to solve the second unknown, which is the weight of the salt in dynes represented by the variable capital W. We recall the first solved unknown, and some of the given at step 2. We are also going to use this conversion factor. 1 dyn is equal to 1 gram mass centimeter per second square. We manipulate this conversion factor for us to use it as we proceed to solve for the second unknown. We know the weight is equal to the mass of a body multiplied by the local gravity. Then, we substitute the variables concerned and multiply the conversion factors. Then, we cancelled out the units. Finally, we get the weight of the salt in dynes, which is 328,235.1 dynes. We box the answer and the second unknown has been solved. The last unknown is the weight of the salt in gram force. Our approach is that we will convert what we obtained at the second unknown. Then, we are going to use this conversion factor. 1 gram force is equal to 980.66 dynes. And then we multiply the second unknown and the conversion factor. Then, we cancelled out the units. Finally, we get the weight of the salt in gram force, which is 334.71 gram force. We box the answer and all unknowns of the problems has been solved. Follow for more.